So, what if I told you there's a new blueprint for materials R&D? One that really gets to the heart of the biggest challenge we all face: how to discover truly novel materials without just taking a blind shot in the dark. Let's dive in and see how it works. If you're an R&D leader, you know this dilemma all too well. It's a constant balancing act, right? Do you put your resources into optimizing what you already have, making those small, steady improvements to materials you know inside and out? Or do you take that big, risky leap into the unknown, chasing a breakthrough that could change everything? It's that classic tug of war between exploitation and exploration. I want you to think about the entire universe of possible materials, like this giant map. The colorful spots, well, that's your comfort zone. That's the territory you've already charted. You've got tons of data, your models work great there, and you can reliably make things a little bit better. That's exploitation. But then you've got all that white space. That's the exploration zone. Vast, unexplored continents where the next revolutionary material is probably hiding. The only problem? The risk is off the charts. And here's the rub. Our current data-driven tools, they are fantastic at what's called interpolation, basically making predictions inside those well-known areas. But they completely fall apart when you ask them to extrapolate, to guess what's going to happen out in those uncharted, data-poor regions. And that right there is the bottleneck that's been holding back true, game-changing discovery. So how do we break through that wall? Well, the answer isn't just more data. It's about unlocking a totally different kind of intelligence, expert knowledge, but supercharged with AI. Just imagine this for a second. What if you could take all of your own hard-won proprietary data and fuse it, truly integrate it with decades of human expertise that's currently locked away in millions of scientific papers? That's the big idea here. We're going to use AI not just to crunch your numbers, but to read, understand, and pull out critical knowledge on a massive scale. And we're not just doing a generic web search. No, this approach gets super specific. We're essentially training large language models to become domain experts in the 5 key areas that are absolutely critical for designing alloys. We're talking corrosion science, materials mechanics, metallurgy, solid-state physics, and of course, the big one that ties it all together, materials science. This quote really just nails the paradigm shift we're talking about. AI stops being just a data-crunching machine. It becomes our tool, our key to unlock this enormous, unstructured library of human knowledge and turn it into something we can actually use to make discoveries. Okay, let's get into the nuts and bolts. How does this blueprint actually work? How do you take that hard data and combine it with this AI-powered knowledge? The whole framework is built on a really elegant, fundamental idea in material science, the elemental substitution principle. The Lego analogy here is perfect. A lot of the time, you can take 2 elements that are chemically similar and just swap them out, like trading a red Lego brick for a similar blue one, and you can create a brand new alloy without totally messing up the original structure. So, the system gathers evidence from 2 main places. First, it digs into your existing material datasets. It looks for patterns for times when elements have been swapped successfully in the past. At the same time, it goes and asks the AI expert direct questions. Things like, hey, in this type of alloy, can you substitute manganese for copper? So now you've got these 2 powerful, independent streams of evidence to work with. But wait, this creates a whole new challenge, right? You've got your data, you've got AI experts. What happens when they disagree? How do you manage that risk and actually trust the final answer? This is the exact question every executive should be asking. If my data points one way, but an AI model points another, how do I make a multi-million-dollar bet on which one is right? You need a system that gives you more than just an answer. You need it to tell you how confident it is in that answer.
And the solution is brilliant. It's a framework called Dempster-Shaver theory. Now, don't worry about the name. Just think of it as a really, really smart and impartial judge for all your evidence. It doesn't get forced into a simple yes or no. Instead, it looks at everything and delivers a verdict that includes belief, disbelief, and most importantly, a clear measure of uncertainty. It has the power to say, you know what? Based on the evidence we have, we just don't know enough to make a high-confidence call.
The process itself is just beautifully systematic. 1. Gather the evidence from your data. 2. Gather the knowledge from your AI experts. 3, and this part is so important, the system automatically figures out how reliable each of those sources is for the specific question you're asking. And finally, 4, it combines everything to give you a single, unified prediction, complete with that all-important uncertainty score. And this right here, This is the real takeaway for any R&D leader. This framework completely changes how you make decisions. You're no longer taking blind guesses in that big, unexplored territory. You're making calculated, de-risked investments because you have a clear, quantitative handle on what you know and what you don't know. That means fewer failed experiments and a much faster path to market. All right, so let's talk about the payoff. What happens when you actually put this evidence engine to work? Well, you get a completely new kind of map to guide your discovery program. The results, they kind of speak for themselves. The framework was tested on alloy systems with elements it had never seen before in the data. This was a pure extrapolation test, the hardest test there is, and it nailed it with 86 to 92% accuracy. That is an absolute game changer for exploring new chemistry. So remember that big, scary map from the beginning with all the white space? Well, look at it now. The framework takes that map and overlays it with strategic intelligence. It shines a spotlight on the most promising areas to explore, but it also colors them by the level of risk, effectively de-risking your R&D pipeline before you even run a single experiment. And what's really cool is that it's not a black box. The system gives you answers you can actually understand. It doesn't just say, this alloy will work. It can explain why it thinks that, based on what it's learned about elemental substitution. For example, it can lay out the reasoning for why chromium and niobium are good substitutes in certain cases. That builds trust and gives you real scientific insight. And you might be thinking, okay, that's great for high-entropy alloys, but what about my materials? Well, this thing is not a one-trick pony. After proving it out on HEAs, it was successfully applied to a totally different class of materials, high-entropy borides. That proves the underlying concept is a versatile platform ready to be applied to any complex system with lots of components. So let's zoom out. What does this all mean for the future? Well, this blueprint isn't just a new tool. It could fundamentally reshape the entire R&D pipeline. The potential here is just huge. This isn't just about alloys. You can use this to accelerate discovery across your entire portfolio. Think functional ceramics, catalyst materials, anything where you're dealing with complex combinations and not a lot of data. It's a force multiplier for your whole organization. And it doesn't even stop there. The next evolution is already being planned, combining this framework with active learning. Imagine a system that not only points you to promising new materials, but also tells you the single most valuable experiment to run next to reduce your uncertainty. You'd have a fully closed-loop optimized decision support system for your entire lab. Look, this is more than just a new piece of software. It's a new blueprint for discovery itself, one that finally integrates our data, our collective knowledge, and a smart way to manage risk. It takes the vast unknown from being a scary liability and turns it into your biggest strategic opportunity. So the only question left is your R&D pipeline built for it?